Good morning, students. Today we shall start with your new chapter, second, that is structure of atom. Now, you know that the charge on the atom is neutral because it consists of equal number of protons and electrons. The fundamental particles of the atoms are electrons, protons, and neutrons. Electrons are that type of fundamental particles which carry 1 unit negative charge and has mass 9.1 into 10 raised to power minus 31 kg. Similarly, proton, it is that fundamental particle which carries 1 unit positive charge and has mass 1.67 into 10 raised to power minus 27 kg. Neutrons, these are the third fundamental particles which carries no charge and has the mass same to that of proton, that is 1.67 into 10 raised to power minus 27 kg. So students, these are the fundamental particles of the atom: electrons, protons and neutrons. The electrons are being discovered by J.J. Thomson, and protons are discovered by Goldstein, and neutrons were discovered by James Chadwick. Now, after the discovery of electrons, protons and neutrons, how these fundamental particles are arranged within the atom, in order to answer this, two models as proposed earlier are briefly explained here. First model is J.J. Thomson model. According to it, he considered atom as a sphere of positive charge in which electrons are being embedded. This model is compared with a watermelon in which the seeds are embedded. That's why this model is also called watermelon model. Now, the limitation of this model is, although it is able to explain the overall neutrality of the atom, but it could not explain the results of Rutherford scattering experiment, which you will do later. Now, come to the second model, that is Rutherford model. What he did, he struck alpha particles with a radioactive substance. Students, alpha particles is a particle which carries 2 unit of positive charge and has mass nearly 4 times that of proton. In other words, these particles are nothing but helium nuclei. Now, when he did this experiment, he made certain observations and drew conclusions from them. First observation was 99% alpha particles went straight without any deflection. It means he concluded from it that most of the space in an atom is empty. Second observation was few alpha particles undergo deflection through small or large angles. He made a conclusion from it that there must be some positively charged body present inside the atom. And third observation was very few alpha particles retrace their path. From this, he concluded that there is a direct collisions of these alpha particles with positively charged body inside the atom. So thus, according to this Rutherford model, the atom consists of two parts. First is nucleus and second is extranuclear part. In nucleus, protons and neutrons are present, and in extranuclear part, it is the space which is around the nucleus, and in it the electrons are distributed. So that was the Rutherford model. Students, now come to the next topic, atomic number and mass number. you all of you are aware that there is no charge on the atom. That is, atom is electrically neutral because the number of protons present in it is equal to the number of electrons. This number is called atomic number. Hence, atomic number of an element is equal to total number of protons present in the nucleus, which is equal to the total number of electrons present in the neutral atom. Now come to the mass number of an element. It is the summation of protons and neutrons. So, mass number of an element is equal to number of protons plus number of neutrons. Students, the notation of atomic number is Z and mass number is A. So, the atomic number, that is Z, and mass number, that is A, of an element X are usually represented along with the symbol of the element as represented on the right hand side. Next, come to certain definitions which are associated with the element. First one is isotope. Look at the example. The three isotopes of hydrogen. First one is protium, that is H11. Second is deuterium, that is H12. And third one is tritium, that is H13. Subscripts are atomic number and superscripts are mass numbers. So here we note that first these are the atoms of the same elements which have the same atomic number but different mass number. So such species are known as isotopes. Now come to the isobars. If we consider the example argon, potassium and calcium, these are the atoms of the different elements. All these different elements have the same mass number but different atomic numbers. So such species, these are known as isobars. These are just the vice versa of isotopes. Next, come to the isotones. Now students, consider one example, carbon and nitrogen. Carbon 14,6, nitrogen 15,7. If we consider their neutrons, in carbon 14 minus 6 is 8. In nitrogen 15 minus 7 is 8. So both these species have the same number of neutrons, although their atomic number and mass number are different. So such atoms of different elements which contains the same number of neutrons are called isotones. Next is isoelectronic species. Iso means same, electronic means electron. So such species which contain the same number of electrons are known as isoelectronic species. For example, O2 negative, F negative, Na1 positive and Al3 positive. These species we have considered in which protons are 8, 9, 11 and 13 respectively. But in all these species, electrons are 10. So such species are known as isoelectronic species. Now, consider one numerical in which you are asked to find out the atomic number, mass number, number of protons, electrons and neutrons present in the element uranium 92 to 38. Here in this species, the subscript is the atomic number and superscript is the mass number. So atomic number is 92 and mass number A is 238. And we also know that number of protons is equal to number of electrons, which is equal to atomic number. So in it, the protons and electrons both are 92. Also, number of neutrons is mass number minus atomic number, which will come out to be 146. Now students, you have to retain in memory that in a neutral atom, number of protons is equal to number of electrons, which is further equal to atomic number. and in a negative ion, Xn negative. Number of electrons is always greater than number of protons. So number of electrons here will be Z plus N. Z is the atomic number and N is the number of particles carrying negative charge. In a positive ion, Mn positive, number of electrons is less than number of protons. So the number of electrons here is Z minus N. However, number of protons is always Z and number of neutrons is always A minus Z. Come to the next topic, electromagnetic wave theory. This theory was put forward by James Clerk Maxwell. There are certain postulates on which this theory depends. The first postulate, the energy emitted from any source like the heated rod or the filament of a bulb through which the electric current is passed. So the energy emitted in it is continuously in the form of radiations and this is called radiant energy. Its second postulate, these radiations consist of electric field and magnetic field. Both these components are perpendicular to each other as well as perpendicular to the direction of propagation of the radiation. Third postulate, these radiations, they travel with the velocity of the light, which is 3 into 10 raised to power 8 meter per second. Students, because of these characteristics, these radiations are called electromagnetic radiations. One more postulates, these radiations do not require any medium for their propagation. For example, rays from the sun reach us through the space, which is a non-material medium. There are some important characteristics of a wave like its wavelength, frequency and velocity. Now students, the height of the wave is known as crest or depth of the wave is known as trough, and this height or the depth of the wave is also known as amplitude. Now the wavelength of a wave is defined as the distance between any two consecutive crests or troughs, and it is represented by lambda and is generally expressed in angstrom, meter, centimeter or nanometer or picometer. Next is frequency. Frequency of a wave is defined as the number of waves passing through a point in 1 second. Its notation is nu and is expressed as hertz or per second. Now come to the velocity. Velocity of a wave is the linear distance traveled by the wave in 1 second. Its notation is c and is expressed in meter per second or centimeter per second. There is one more term, wave number. Its notation is nu bar and it is defined as the number of waves present in 1 centimeter length. Evidently or clearly it is equal to the reciprocal of the wavelength. Now students, the relation between velocity, wavelength and frequency of a wave is c equal to nu lambda. Now next come to the electromagnetic spectrum. Students, there are large number of electromagnetic radiations like cosmic rays, gamma rays, X-rays, UV rays, visible, infrared rays, microwaves, radio waves. When these electromagnetic radiations are arranged either in order of increasing wavelengths or decreasing frequency, then the complete spectrum obtained is known as electromagnetic spectrum. In this spectrum, cosmic rays, they have the highest frequency and least wavelength, but the radio waves, they have the maximum wavelength and least frequency. Since the wavelength and frequency, they are inversely related, you know that C equal to nu lambda. So the frequency and wavelength are inversely related. Now come to the numerical, in which you have to calculate a wave number and frequency of yellow radiations having the wavelength 5800 angstrom. Student, 1 angstrom is 10 raised to power minus 10 meter. So the wavelength is 5800 into 10 raised to power minus 10 meter. And you know that wave number 1 over lambda. So on substituting the values, you will get 1.72 into 10 raised to power 6 per meter. Now, in second case, you have also to calculate the frequency nu equal to C over lambda. C is well known to you, 3 into 10 raised to power 8 meter per second. Wavelength is given to you. So, inserting these values, you will get the frequency 5.172 into 10 raised to power 14 per second. Students, there are certain limitations of electromagnetic wave theory. According to this theory, we cannot explain black body radiations and second photoelectric effect. Now come to first black body radiation. For this, first you know what is black body. Black body is that which is a perfect absorber and perfect radiator of energy, that is, which can emit and absorb all frequencies. And if the substance being heated is a black body, the radiations emitted is called black body radiation. Students, if any substance with high melting point, for example an iron bar, is heated, firstly it becomes red and then yellow and finally begins to glow with white and then blue light. Now, according to electromagnetic wave theory, the energy is emitted or absorbed continuously. So, according to it, the energy is directly proportional to the intensity or square of the amplitude and does not depend on the frequency or wavelength. So, according to it, the radiations emitted by the body being heated should have the same color, although its intensity may vary as the heating is continued. But the change of color shows that on heating, the frequency of the radiations emitted is increasing. This theory is unable to explain black body radiation. Next is photoelectric effect. Now, what is photoelectric effect? When we fall the radiations of certain minimum frequency on the surface of the metal, then the electrons from the surface of the metal will be ejected out. This phenomena is called photoelectric effect. Now there are certain observations of this phenomena. First is the electrons are ejected only if the radiation strike the surface of the metal has at least a minimum frequency or called threshold frequency. If the frequency is less than threshold frequency, there will be no ejection of electrons. The minimum energy required to eject the electron is called work function. So students, in order to have this phenomenon of photoelectric effect, the radiation fallen on the surface of the metal must have minimum frequency, that is known as threshold frequency, so that it can overcome the force of attraction between the electrons and protons and the electrons get ejected out. The second observation was the velocity and hence the kinetic energy of the ejected electron. It depends upon the frequency of the incident radiation and does not depend on the intensity. So more the frequency of the incident radiation, more will be the kinetic energy of the ejected electron. Third observation was the number of photoelectrons ejected. It is proportional to the intensity of the incident radiation. So, more the intensity of the radiation of certain frequency, more will be the number of photoelectrons ejected. So students, these three observations can't be explained by electromagnetic wave theory, because according to it the radiations are continuous, so it is possible to accumulate the energy on the surface of the metal irrespective of its frequency, and thus the radiations of all the frequencies should be able to eject the electron. To explain the phenomena of black body radiation and photoelectric effect, certain theory known as Planck's quantum theory was put forward. The main points of this theory, the first is the energy emitted or absorbed is not continuously but discontinuously in the form of small packets of energy, and these packets of energy is called quantum, and in case of light this is called photon. Its second point is the energy of each quantum is directly proportional to the frequency of radiation, that is E equal to h nu, where h is the proportionality constant and is called Planck's constant. Its value is equal to 6.626 into 10 raised to power minus 34 joule second. The third postulate is the total amount of energy emitted or absorbed will be some whole number quanta, that is E equal to nh nu, where n is any integer. So students, the main difference between the electromagnetic wave theory and Planck's quantum theory is that in case of electromagnetic wave theory, the radiations emitted or absorbed are continuously, but in case of Planck's quantum theory, the radiations emitted or absorbed is discontinuously in the form of packets which are called quanta. Now, this Planck's quantum theory is able to explain both black body radiation and photoelectric effect. Now, first, let's consider the explanation of black body radiation. Substance is heated, the atoms of the substance are set into oscillation and emit radiations of frequency. Now, as the heating is continued, more and more energy is being absorbed by the atoms and they emit the radiations of higher and higher frequency. As red light has minimum frequency and yellow has higher frequency, therefore the body on heating first becomes red, then yellow, and so on. Now, next come to the explanation of photoelectric effect by using Planck's quantum theory. Now students, when a light of some particular frequency falls on the surface of metal, the photon gives its complete energy to the electron of the metal atom. The electron will be dislocated or knocked out only if the energy of the photon is sufficient to overcome the force of attraction of the electron by the nucleus. That is why the photoelectrons are ejected only when the incident light has a certain minimum frequency called threshold frequency. Now, if the frequency of the incident light nu is more than threshold frequency nu naught, then the surplus energy h nu minus h nu naught is imparted to the electron as kinetic energy. That is, kinetic energy of the ejected electron half mv square equal to h nu minus h nu naught. Now, with increasing the intensity of the light of a given frequency, the number of photons will increase, but there will be no increase in the energy of photon. Hence, when the intensity of the light is increased, more electrons are ejected, but the energies of these electrons are not altered. So, this is the explanation of photoelectric effect on the basis of quantum theory. Now, let us solve two numericals. In first numerical, you have to calculate the energy of a mole of photons of radiations whose frequency is 5 into 10 raised to power 14 hertz. Student, you know that according to Planck's quantum theory, E equal to h nu. This is the energy of one photon. The value of h is fixed, which is 6.626 into 10 raised to power minus 34, and you are provided with the frequency, so the energy of one photon will come out to be 3.313 into 10 raised to power minus 19 joule. Now we are asked to find the energy of 1 mole of photon, so you have to multiply this energy with Avogadro number, which is 6.022 into 10 raised to power 23. On solving it, you will get the answer 19,951 joule per mole. Now come to the second numerical. When electromagnetic radiation of wavelength 300 nanometer falls on the surface of sodium, electrons are emitted with a kinetic energy of 1.68 into 10 raised to power 5 joules per mole. What is the minimum energy needed to remove an electron from sodium? And what is the maximum wavelength that will cause photoelectron to be emitted? So students, first we will find the energy of photon. So E equal to h nu, and nu we know that C over lambda. So E equal to h C over lambda. On substituting the values, you will get 6.626 into 10 raised to power minus 19 joule. So student, the energy of one photon is this. So 1 mole photon will be, you have to multiply it by Avogadro number, which you will get 3.99 into 10 raised to power 5 joule per mole. Now you know that E equal to E naught plus kinetic energy. This is according to the formula. E is the total energy, E naught is the threshold energy, which is also known as work function. So E naught is equal to E minus kinetic energy. On substituting the values, you will get 2.31 into 10 raised to power 5 joule per mole. So we have to calculate, but here minimum energy to remove one electron. So you have to divide it with Avogadro number to get the energy of one electron, and it will come out to be 3.84 into 10 raised to power minus 19 joule. Now in second part, you have to calculate the wavelength corresponding to this energy, and its formula is E equal to hc over lambda. So lambda equal to hc over E. So on substituting the values, you will get 5.17 into 10 raised to power minus 7 meters. So this is the maximum wavelength.